K components, maximum number of edges in G is. There are 4 options are given. It is given that graph G contains n vertices and K components. If a simple graph contains n vertices and K components, then maximum number of edges possible would be, the number of edges is less than or equal to n minus k into n minus k plus 1 by 2. So here maximum number of edges in graph G would be n minus k into n minus k plus 1 by 2. So here correct option is, this is a standard result. So here correct option is option D. The minimum number of edges in a connected cycle graph on n vertices is. Here 4 options are given. Option A is n minus 1, option B n, option C n plus 1, and option D none of these. A simple graph with n vertices is said to be cycle graph if all the edges form a cycle of length n. It is denoted by Cn. So let us take cycle graph with 3 vertices. So this is a cycle graph with 3 vertices. This would be a cycle graph with 3 vertices. This would be cycle graph if it contains cycle of length 3. If we can't remove one edge from this. Why? Because if you remove at least one edge, this will not become cycle graph. So here the number of edges is 3. So let us take cycle graph with 4 vertices. Here also we need all the 4 edges in order for the graph to be cycle. So here the minimum number of edges, would be 4. So here the minimum number of edges number of edges in a connected cycle graph on n vertices is n, because we need all the n vertices, then only it will be cycle, otherwise it will not be cycle graph. So here correct option is option B. For full emery tree of height h as L leaves with L less than m power h, B, option B, L less than or equal to m power h, C, L greater than m power h, and D, L greater than or equal to m power h. In order to solve this problem, first of all we need to know what is full emery tree. Emery tree is nothing but a tree for which each node has at most m children. This is the definition for emery tree. Full emery tree. What is full emery tree? An emery tree in which each internal node has exactly m children. An emery tree in which each internal node has exactly m children. This is the definition for full emery tree. Here it is given that height of full emery tree is h leaves and it contains L leaves, and we have to find the relationship between leaves and the height. So let us take one example. Let us solve this problem by taking one example. So let us construct an memory tree. Let us take binary tree where here m is nothing but 2. That means every node has at most 2 children. So if we take a full binary tree like this, let us suppose height root is at height 0, height 1, and this is at height 2. So the height of this tree is 2, and here number of leaves is 1, 2, 3, 4. That means 2 power h. Here L is equal to 2 power h. This is example for full binary tree. Let us take one more tree. This is also example for full binary tree. Why? Because in full binary tree, each internal node has exactly 2 children. Here each internal node, these are the internal nodes, and internal nodes have exactly 2 children. So we can take this as full binary tree. So here number of nodes is, here height is 0, 1, 2, and this is 3. And the number of leaves is 1, 2, 3, 4, 5, 6. It means 6. L is equal to 6, which is less than or equal to 3 power, sorry, 2 power 3, 8. So here we can say if h is the height of the full binary tree, full memory tree, the number of leaf nodes is at most m power h. That means L is less than or equal to m power h, where L is the number of leaves. So here correct